Okay, so now that we've got our neck bones in place, let's go ahead and create our head controls. That's both our attached control that will be parented into the result of our shoulder control blending, and also our detached control that will be parented to our master control. We can also then set up our dynamic control parenting asset, a new instance of that asset, in order to set up our head controls. So I'm going to start out by creating our head control, and to do that I want to get the position of the end of our neck. So I'm going to branch off of neck bone 3 with a new null, and then I'm going to use that to get the position. So let's hunt down neck bone 3, and I'm going to wire a new null off of the end of neck bone 3. I'm going to name this to head underscore shoulder control parent underscore initial position. And I want to translate down, if we come over here in the perspective view, let me turn off the visibility of the goblin. There we go. I want to move down to the end of that bone. That means I want to translate in Z to the end of the bone. Now, since this isn't a control that will always be parented into the neck, I'm simply after the position currently at the end of the neck. I'm going to do this using a value rather than using an expression. So I'm going to move down a negative, in my case 0.87, and a small amount after that. So that's going to move us down to the end of the neck. I can now keep position when parenting and unparent from the neck. And that will allow me to grab that position as a world space position. I do want to go ahead and zero out all of our rotations, since I'm only interested in the position. I'm not interested in the rotations. And since this is our shoulder control parent, let's go ahead and parent this in to the blend result of our shoulder control. So I'm going to parent that to the shoulder control blend result, of course, keeping position when parenting, and zero out the very slight inaccuracies that were in the rotation there. So that's going to serve as our initial position, and we're going to set up these controls in the exact same way as the shoulder controls were indeed set up. That means we're going to have initial position null with a control object from that null and an editable version of the control object from that null. We'll then go ahead and blend the two control objects, wire into a new null that will be the blend result with some expressions on. In this case, we're only going to be worrying about the twist expression. Then we can drop in an instance of our dynamic control parenting asset and get everything hooked up into that asset. So I'm going to go and wire a new null off of this initial position. So let's turn off its visibility and selectability. Wire this into a new null, and this will be our head control underscore shoulder control parent. So I'll give this a blue node color, since indeed this is going to be a control object. I'll give it a yellow wireframe color, and I want this to be a circles type of control, but rather than specifying circles, because I actually need to offset the center point of those circles, I'm going to use a custom control type. Now you may think, well, why don't we just use circles, position the circles, and then offset our pivot in order to rotate? That would be fine if we weren't doing control matching. Unfortunately, the control matching will not work if we offset our pivot point. If we offset our pivot point, that actually changes the rotations and translations that we need inside our transform in order to get the same orientation and position that we're in, because now we have an offset pivot. The set world transform method call doesn't take into account your pivot, and so this will actually break our control matching. So I'm actually going to keep the pivot at 0, 0, 0, but instead I'm going to offset the control by creating a new custom control type. So let's set our control type to custom. I can then jump down inside our control, and from inside our control I'm going to create a new circle sop, and this circle sop is going to be a NURBS circle. So it's a NURBS curve, and I am going to make sure that if I turn my visibility over here, we currently have a surface. If I set this to an open arc, that will remove that surface. So I want to set the radius up, boost the radius up probably to something like 2.75. will work out fantastically for the size of our head. So we've got our circle sop. I'm then going to copy and paste this twice over, changing this to the YZ plane and also to the ZX plane. If we merge these together now, you'll see that that will indeed give us that circles type control object. Now I want to transform these, translate these down at the SOP level. To do that, I should really go ahead and turn on the visibility of our goblin geometry. We can then jump back down inside that head control control object, wire this into a transform SOP, and we can use that transform SOP to offset the pivot point of this control. So let's jump into a side view with space 4, and I want to offset this up. We know we're centered in X, but I do want to offset this up slightly in Y, and also forward slightly in Z, so that we actually sit around our head, maybe even a little bit further. There we go. So we are indeed centered up on our head. If we now jump in and turn on shaded view, you can see that by offsetting that, we have indeed made our control sit around our head. If we didn't have that, our control would look very odd indeed. So I'm actually going to keep that offset in place. We can wire into the control SOP. That will give us our yellow wireframe color. And that's going to be our control object in place. So now that's in place, we can go ahead and actually turn off the visibility of our goblin geometry. So we've got that control object in place. I want to add a twist offset parameter to that control object. We know that indeed we will need that for our twist calculations. We expect that parameter to be on the control object. So let's go ahead and add that twist offset parameter to the control object. And we also, because of the fact that again we're dealing with twist, and again we're dealing with rotate Y being the most important rotation, let's set our rotate order to rotate Y, rotate X, and then rotate Z. So that's going to be our rotate order, making rotate Y the most important rotation. So we have our control, we still need our editable control, so I'm going to middle click to branch off of that initial position and create a new null. And this time I'm going to name this to head control underscore shoulder control parent underscore editable. And this will act as our editable version of that control object. Again, our control has no pre-transform, neither does our null. They share the same parent. That means that they are indeed going to exist in the same space. As before, we do need to make sure that we match their rotation order, so rotate Y, rotate X, rotate Z on both of those control objects. So we've got our head control in place for the shoulder control parent. We do indeed still need our head control for the master control parent. So let's grab all three of those nodes, the initial position, the control, and the editable control, Control C to copy, and Control V to paste those. I will go ahead and move that over to this side. I'm going to rename these according to the fact that they're now going to be for our master control. So I'm simply going to rename them, taking out the word shoulder and replacing that with the word master. So now we have the initial position, we have our editable version, and our master control parent. It's all for our master control. We do of course need to take that initial position and actually reparent it in whilst keeping position to our master control. And that will reparent us into the master control. I will zero out those very slight inaccuracies in terms of rotation, just so we have zeroed rotations. But other than that, that's now our master control objects also set up. Except for following our color convention, we need to change our wireframe color for the detached control to orange in order to infer that that is indeed detached. So I'm going to blend between these two head controls. So I'm going to wire our shoulder control parent into a blend, and then the head control master control parent into that blend as the second input into that blend. And let's rename this to blend head control. And now that we have this, to drive the parameters on this blend, amongst other things, I need an instance of our dynamic control parenting asset. I will turn off visibility, selectability of that blend. I will also move these two neck curve controls just out of our way for a second. So let's go ahead and create a new instance of our dynamic control parenting asset. So I'm going to push tab and type dynamic, and there we go, dynamic control parenting. So there's our dynamic control parenting asset. In this case, I want this to become our head dynamic control parenting, and without that underscore on the end there, fantastic. And I'm just going to use this for now for the blend parameters. So I'm going to copy that blend parameter. We know that we want a weight of 1 minus that blend parameter for weight 1, so that when we're at a value of 0 we have a value actually weight of 1, and then when we're at a value of 1 we want a weight of 0. So I'm actually going to paste a copied relative reference, but then use 1 minus that reference for weight 1. The reverse is needed for weight 2, we just need that reference itself. So now if I was to grab our detached control object and move that out of the way, let's bring the visibility just for a second back on our blend. Then if we were to blend back and forth between these, you'll see we're either attached towards yellow control or detached towards the orange control rather. So there we go, we have our control objects and they're now being blended based on the parameter on our asset. We also need to control the visibility of these guys based on that parameter on our asset. So let's jump to the attached control, and we want this to be equal to having its display all the time. We're not quite equal to 1, so I'm going to paste a copied relative reference. We want that blend, as long as it's less than 1, then indeed we want to be visible. In the same way, we're going to paste a copied relative reference on the detached control, and that's visible all the time we're greater than 0. You can see our detached control has now become invisible. If we move our detached control back, as we blend up from 0 towards 1, they both become visible. Once we hit 1, the attached control becomes invisible. So now the visibility of the controls is working also. So before we actually create our setup on the asset itself, specifying our attach object, editable attach, etc., we need to create that final result object. So that's going to be a null that's a child of our blend head control. So let's create a new null. And this is going to become our head control underscore blend result. And as before, since we're dealing with our twist calculations, we look for the twist angle parameter to exist on this particular null. So we're going to edit the parameter interface, create a new float, and this is going to be our twist angle parameter. We need to enter an expression that's almost identical to the expression we had down on our shoulder control blend result. The only difference here, of course, we're referencing head controls as opposed to shoulder controls. So this is, in theory, the exact same expression. So I'm not just pulling this out of thin air. This is the expression that we developed over the last few videos. I'm just adapting it to our head control. So we need 1 minus our head dynamic control parenting blend. And that's going to be now for when we want our control to be attached. So 1 minus that for our attached control. And of course we want to multiply that by our attached head controls twist offset added to our attached head controls rotate Y. So we're going to take our head control underscore shoulder control parent, that is our attached control. We want his rotate Y. We also want to add his twist offset into that as well. So head control underscore shoulder control parent, and we want his twist offset. Close off the multiplication. So we're going to add those together first, and then we're going to multiply that by 1 minus our blend. Going to drop down to a new line just to keep things nice and clear. We now need to deal with what happens when we want our detached control. That means we're going to multiply by our head dynamic control parenting blend, and we're going to multiply. In this case we want to take again the rotate Y of our control object. In this case that's our head control master control parent, and we want to subtract from that the originally back with the shoulders we were subtracting our hips rotate in Y. Now in this case I want to rotate what is the end result of the rotations in Y on our shoulders. Now the easiest way to get at that shoulder rotation, we basically want to know what is the twist that's at the top of our spine already. We want to know how much of a twist has been applied from that base of the spine so that we can know how to get from that twist to our current particular rotation. So we can basically reference the twist angle that's on that shoulder control blend result. That will tell us the rotation that's applied to the top of our spine, and then we can find out our relative rotation from that point. The reason we're doing that, of course, is that we don't want to go ahead and simply reference the particular rotate Y of a control, because that's not taking into account how the shoulders are blended, and that's also not taking into account those twist offsets that we've created. If we reference a twist angle, we have all of that taken into account for us. So we're going to take the rotate Y of our head control, master control parent. We're going to subtract from that the shoulder control, blend result, twist angle. And then finally we're going to add onto that our head control, master control parent, twist offset. Close off the brackets for all of those additions before we go ahead and multiply that with our blend parameter. So that's going to be our twist angle expression. Again, this is identical to the twist angle expression that we had working over on our shoulder controls. We can test this out very quickly. We can jump in, and I'm going to pin the parameters on our head control blend result. We can jump in with our attach control, and if we rotate our control, that will give us, or indeed should give us, a twist angle. Obviously something's not being referenced quite correctly. So indeed we are getting a rotate Y on this control object. We are indeed blended to attach. So let's take a look at why that expression isn't quite working properly. It's possible, and indeed I missed off a bracket, so we actually had a bracing error there. So including that bracket on the end of the 1 minus, that should hopefully have fixed up the bracing error, and that should now give us a twist angle of 53 degrees. Fantastic. So that is now working as we increase. If we grab our head control again, let's lock our parameters, grab our head control. You can see we can increase that twist angle. We can decrease that twist angle. And if we increase that twist angle, then grab our shoulder controls, since we're attached, that'll have no effect whatsoever. Fantastic. So let's grab our head control and make sure we zero him back out. I'm then going to pin again. Well, before we do that, let's blend over to our detached control. Fantastic. Pin our parameters. Now we can take a look at what happens with our detached control. Indeed, we can increase the twist angle. If we take our shoulders now and rotate them towards the head, you're going to see we decrease that twist angle, or indeed we increase that twist angle as well. So that is working there. The last final test that I'd like to do is, if we blend back over to the attach, I do want to zero out our detach control. I want to test out our twist offsets. If I put 100 degrees on the twist offset for the attach, we have a twist angle of 100. Fantastic. If I put 100 degrees on the twist offset for our detach and blend over to the detach, we have a twist angle of 100 as well. So that is working fantastically. Now, we're not going to worry about getting the twist actually set up in this video. We'll be dealing with that in the next video, but it would be really useful to go ahead and get our head dynamic control parenting asset set up so that we can match between our attach and our detach. Also, now that we have the result of this, we know this will be the final position and orientation of our head control. Let's take our control 2 and control 3 for our neck curve, turn off their selectability, their visibility, and also their node color, and whilst keeping position when parenting, parent them into the head control blend result. That now means if we grab our head control, we're going to be taking our neck with us. Of course, we do have that lock for spine stretchiness down on the master control. With that set to a value of 0, we will not be able to stretch our neck out. So that's all still working fantastically. Let's set that spine stretchiness back up to a value of 1. So all that's left to do now is to set up our head dynamic control parenting asset. So let's hunt down our head dynamic control parenting asset. We are not blending rotate X, because in this case we're not worried about rotate X, we're only worried about the twist. And that's exactly why with our spine we set up the dynamic control parenting, so we had the ability to turn off blending of rotate X. That's because I knew with our head we would not need rotate X. Now our attach object, that's going to be our head control, the shoulder control parent. Our editable attach object will be the head control, shoulder control parent editable. The detach object will be our head control, master control parent. The editable detach object will be the head control master control parent editable. And that final result object is going to be the head control blend result. So if we specify all of these on our asset, we should now be able to go in and start matching between our different head controls. So let's move our attached head control over. Let's rotate our attached head control slightly. Let's grab our neck, or our shoulders rather, and rotate those just so that our attached control has a crazy position and orientation based on both of these guys. And of course the arms are going to look a little bit crazy, that's fine. We're only worried about what's happening with our head control right now. So now if we took a look at our detached, there's our detached, there's our attached. Let's match the detached to the attach, and fantastic, they are aligned perfectly. That is fantastic. I'm going to undo back to where our detach is still over here. If we match our attach to our detach, they are both aligned perfectly. So let's go ahead and grab our shoulders, zero out the rotations on our shoulders. Let's grab our head dynamic controls, blend back over to the attached. And now that we zeroed out the rotations on our shoulders, of course, our head control itself is in the incorrect position. So let's zero out each of those parameters. So now everyone is back to their default location. So that's going to finish setting up the head controls themselves. In the next video, we can turn around and actually get the twist angle that we're calculating being applied to the bones in our neck, and actually have the bones in our neck being rotated based on that twist angle. But this will conclude this video. Thanks a lot, everyone.